Are you struggling with the Softplus function in Python, especially when dealing with large numbers? You're not alone. Today, we're going to tackle this issue and help you avoid overflow errors. I completely understand how frustrating it can be when your calculations return infinity instead of a number. It can feel like you're hitting a brick wall, especially when you're trying to implement something as straightforward as the Softplus function. Here's the specific question we're addressing. A user asked, why does my Softplus function return infinity when x is too large? They mentioned trying it with math and NumPy, but still faced issues with large values like 1000. Sound familiar? Let's dive into this. So what's happening here? The Softplus function is defined as the logarithm of 1 plus the exponential of x. When x becomes very large, the exponential function grows rapidly, leading to overflow. We need a way to handle these large values without running into this problem. And stick around. At the end of this video, I'll share a clever trick to implement the Softplus function safely, even with large numbers. To handle large values in the Softplus function, the user can use a numerical stability technique. First, we will check if the input value is greater than a certain threshold. Next, if the input value is not too large, the user can safely compute the Softplus function using the standard formula. This will ensure accurate results for smaller values. Now, let's implement this logic in Python. The user can define a function that incorporates both checks for numerical stability and the standard Softplus calculation. Finally, the user should test the function with various input values, including large numbers, to ensure it behaves as expected without returning infinity. Fun fact, did you know that the Softplus function is often used in machine learning as an activation function? It's smooth and differentiable, making it a great choice for neural networks. Now, let's look at the answers provided by other users. An alternative solution provided by another user involves creating a safe Softplus function. They define a function that checks if the input is less than 100. If it is, it calculates the Softplus using the standard formula. If not, it simply returns the input value, avoiding overflow. Let's take a look at an answer from another user. An alternative solution provided by another user involves defining a function called safe Softplus. This function uses a limit to handle large values of x. If x exceeds the limit, it simply returns x. Otherwise, it calculates the Softplus using the log1p and xp functions for better numerical stability. Let's take a moment to review another user's answer. An alternative solution provided by another user suggests using TensorFlow's built-in function. They recommend using tf.math Softplus to avoid overflow issues when calculating the Softplus function with large numbers. Here's the trick I promised. By implementing this conditional check, you can avoid overflow errors and ensure your Softplus function works seamlessly, even with large inputs. And there you have it. With this approach, your Softplus function should work perfectly, even with large numbers. If you found this video helpful, please subscribe for more tips and tricks on Python programming.